In this video, we are going to solve linear equations, multi-step linear equations. So here are a few steps we need to keep in mind when we are solving the equations. The first step is, if necessary, simplify the expression on each side of equation. So on the left-hand side and on the right-hand side, individually, if there's any parentheses, there's any like terms that need to be combined, do that first. Second, once you have done that, your goal is to bring all the variables on one side and take all the numbers onto the other side. And then next step would be isolating the variable. So read these steps, and the last step is to check your solution. When you plug the value of variable back into original equation, the left hand side and right hand side should be equal to each other. If they're not equal to each other, that means we've messed up, we've made a mistake somewhere. We need to go back and fix our work. Okay, let's check out first example. Negative 20y plus 15 equals 2. Take away 16y plus 11. Very important to keep in mind, you have an equal sign in the middle, so we are working with two separate sides. Okay, it's an equality. That means the left hand side and right hand side are equal to each other. So whatever we do to one side, we must do that to the other side as well. Okay, let's examine the left hand side and see if there's any like terms that I need to combine. Looks like there's no like terms on the left hand side, but on the right hand side I have two like terms, 2 and 11. They both are like terms because they don't have any variable next to them. So 2 plus 11 is 13, take away 16y. And now the next step, I need to bring variables to one side. So you get to decide whichever side you want to take the variables to. You can take them to the left hand side or to the right hand side. I prefer taking them to the side where my variable will have a positive coefficient. So if I bring the variables to left hand side, I would be adding 16y to both sides. If I take the variables to right hand side, I would be adding 20y to both sides. So in this case, I'm going to choose to take variables to right hand side. That will leave me with a positive number in front of y, positive coefficient for y. So I'm going to add 20y to both sides. Add 20y to both sides. Okay, so that's plus 20y. Again, it's an equation. Whatever I do to one side, I must do that to the other side as well. Okay, I made a small, let's fix this. So there we go. Now I'm adding 20y to both sides. I accidentally wrote it twice. Here we are. On the left hand side, negative 20y and positive 20y will cancel each other, and I'm just left with 15 equals 13 plus 4y. Next step, my goal is to isolate the y. I want to have only this y on this side, nothing else on this side. So I'm going to move the 13 to left hand side by subtracting 13 from both sides. Okay, 13 take away 13, that will be gone from there, and I'll be having 2 equals 4y. Last step, I need to isolate the y. 4 is being multiplied with the y, and I need to undo that multiplication. So I need to do inverse operation of the multiplication. So I'm going to divide both sides with 4. So that leaves me with 1/2 is equal to y. And before I circle this, I should check my answer to make sure that this is correct answer. And if I have made a mistake, my left and right hand side would not turn out to be equal. You always plug it into the original equation, okay? Plug it back into the original equation. So for the checking work, I'm going to plug into negative 20 times whatever I'm replacing the y with. And then I don't know if it's equal to 1/2 plus 11. So I'm putting a question mark in the middle. I'm not sure if left and right hand side are equal to each other or not. If they are equal, my answer is correct. If I followed the steps correctly, my answer should be correct. And checking is just for my own peace of mind. Right, so let's go ahead and simplify. 20 times half is 10, so it's negative 10 plus 15. 2 minus 16 times half is 8. Negative 10 plus 15 is 5. 2 minus 8 is negative 6. Negative 6 plus 11 is 5. So 5 is equal to 5. That means the left hand side is equal to right hand side. My answer is correct, and y is equal to 1/2. So that means the value of the variable is 1/2 in this case. If we replace y by 1/2, then both left and right hand side of this expression are going to be, or both left hand expression and right hand expression will be equal to each other. Only if y is equal to 1/2. Otherwise, they're not equal to each other. Next equation we are going to look at is 4 times 2a plus 3 equals -3 times a minus 1 plus 31. Okay, first thing, looks like on the left hand side I have some like terms to combine, and also on the right hand side I have some like terms to combine. So 4 times 2a is 8a, distributive property, plus 4 times 3 is 12, equals -3a, and -3 times -1 is +3 plus 31. Now on the right hand side I have some like terms to combine. Both of these are like terms, so I'm not going to touch anything else other than combining these like terms, which turns out to be -3a plus 34. Now my goal is to bring the variables on one side, so I'm going to add 3a to both sides. So in the next step, I'm going to write 8a plus 12 plus 3a equals -3a plus 34 plus 3a. So I added a 3a to both sides because I wanted to bring the variables on the left-hand side. Okay, let's see next. There are some like terms I can combine on the left-hand side. 8a plus 3a is 11a plus 12 equals 34. Lastly, my goal is to isolate the a. So the only thing I want to keep here is a. I want everything else to go away. So first I'm going to start by attacking the +12 that is sitting over here. So to undo the +12, I would have to -12 from both sides. And that will leave me with 11a equals 34 minus 12. 34 minus 12 is 22. And lastly, we are going to divide both sides with 11. A comes out to be 2. 22 divided by 11 is 2. And again, the check work. Make sure you check in the original equation, the one you started with. Your left-hand side and right-hand side both should turn out to be equal. So I'm going to first check the left-hand side because I kind of have shorter space here, lack of space. So 2 times 2 plus 3, which turns out to be 2 times 2 is 4 plus 3, which is 4 times 7. 4 times 7 is 28. So my left side is 28. Now let's check the right-hand side. If I replace a by 2, what do I get? -3. 2 minus 1 plus 31. -3 times 2 minus 1 is 1. So that's -3 plus 31. 31 minus 3 is also 28. So both left-hand side and right-hand side are equal to each other. And that's exactly what we wanted. If that happens, that means my solution is correct. And I'm going to box my solution that I got a correct answer here. A is equal to 2. So that means this equation, the left-hand side and right-hand side are equal to each other only if A is 2. For any other value of A, the left and right-hand side are not equal. Okay. Next equation, 1/2 x minus 3 equals 2 minus 3/4 x. This equation has fractions in it, and that's okay. Let's first check left-hand side. Is there any like terms to combine? Not really. Right-hand side, no like terms to combine either. So I'm going to start by bringing variables on one side. Again, when you bring variables on one side, you have a choice to take them to left-hand side or to take them to right-hand side. I'm going to take the variables to left-hand side in this case. So I'm going to be adding a 3/4 x to both sides. So 1/2 x minus 3, 2 minus 3/4 x. I'm going to be adding a 3/4 x to both sides. All right, so that, let's see what does it turn out to be. Now, like terms on the left-hand side that I need to combine, 1/2 x plus 3/4 x minus 3. I'm just writing the like terms close to each other so that they're easier to combine. Now, I cannot add or subtract fractions until my denominators are same. So I'm going to multiply the first fraction top and bottom with the 2 so that I get the common denominator. So that will leave me with 2/4 x plus 3/4 x minus 3 equals 2. 2/4 x plus 3/4 x is 5/4 x minus 3 equal to 2. Okay, now we want that negative 3 to go away. To undo the subtraction of 3, we have to add 3 to both sides. So 5/4 x minus 3 plus 3 equals 2 plus 3. That will leave me with 5/4 x equals 5. Now next step, the 5/4 is being multiplied with x. To undo the 5/4, I'm going to multiply both sides with the reciprocal of 5/4, which is 4/5. So multiply both sides with 4/5. If you multiply both sides with the same things, you are fine. You're not changing the value of the expression, or you're not changing the equation at all, because you're still keeping it balanced on the scale. You're doing the same thing on both sides. So I'm multiplying both sides with the reciprocal of the coefficient of the variable to get rid of that coefficient. Now 4/5 times 5/4 is 1, so that's just x equals 4, and x equals 4 is my solution. Now before I really say this is my solution, again, for my own peace of mind, I need to check. But if you followed the steps correctly, if you did the work correctly, it should always, the left side should always equal the right side. Let's go ahead and check. 1/2 times, let's plug in for x, we're going to plug in 4 minus 3. Let's see if it is equal to 2 minus 3/4 times 4. All right, so that leaves me with 2 minus 3, 2 minus 3. And that's -1 is equal to -1. That means the left hand side is equal to right hand side. So my two sides of the equation are equal here. Okay, next. That means my solution is correct, and I can go ahead and box, circle, highlight, and say that I got it correct. Here's next equation. Again, this one, left hand side and right hand side both have the variables in them, and there's some simplification that needs to be done on both sides. Keep in mind, we are working with two different sides, and it's an equation. Okay, let's start with left hand side. There is a distributive property that I need to start with. 1/2 times 2 is 1, and 1/2 times a is 1/2 a. 1/2 a is same thing as a divided by 2, okay? Keep in mind, 1/2 times a is same thing as a divided by 2, because you can put a 1 underneath and multiply the numerators and multiply the denominators. That's just to keep in mind, okay? Now, on the right hand side, we got 3a plus 4 divided by 9. All right, let's see now. What do we need to do? I want to get rid of the 9 from the denominator here, because I don't like the 3a plus 4 together on the top there. So first thing I'm going to do is I'm going to multiply both sides with a 9. The reason why I'm doing it is to get rid of the 9 from the denominator, and the right hand side I'm just left with 3a plus 4. Left hand side I'm left with 9 times 1 is 9, plus 9 times half is 9 over 2a. All right, now that looks a lot more simpler than what I started with. And the next step, I'm going to bring a's on one side. Again, 9/2 is like 4.5, I think. Yeah. And 4.5 is bigger than 3. So I'm going to bring the variables on left-hand side. It doesn't really matter which side you keep your variables on. You can keep them on the left or right. But doing one can be easier than doing the other choice. So I'm going to keep the variables on left hand side. That means I'm going to subtract 3a from both sides. Okay, on the right hand side, the 3a and 3a will be gone, and the left hand side I have 9 plus, this will turn out to be, when you combine the like terms here, 9 over 2a minus 3a. We need the common denominator, so multiply top and bottom with 2. So it turns out to be 9a minus 6a divided by 2, which is 3 over 2a. So 3 over 2a equals 4. All right, so we want to take the 9 to the other side now. The 9 is being added over here. So I'm going to subtract the 9 from both sides. So subtract 9 from both sides. That way I don't have any constants left on the left-hand side. So 3 halves a equals 4 minus 9, which is negative 5. And now we're going to get rid of the 3 halves in front of our variable a by multiplying both sides with the reciprocal. 2 thirds times 3 halves a is equal to 5 times 2 thirds. Now cancel, 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 cancel. I'm left with a is equal to negative 10 thirds. All right, so that is my final answer. Again, before I actually circle or box or highlight, I will do the check work by plugging that negative 10 thirds into my original equation. So let's quickly do the check work as well to make sure we got the correct answer. I know I got it correct because I did the steps carefully, but it's always nice to, check and make sure you didn't mess anything up. And go slow, one step at a time. So I'm going to plug the a as negative 10 thirds. This is my left hand side, and the right hand side, a is negative 10 thirds plus 4 over 3 squared. All right, and I have the question mark in the middle because I don't know if left side and right side are equal. 1/2, 2 take away 10 thirds. That is going to equal 6 minus 10, which is negative 4 thirds. And the right side, I have negative 10 plus 6. Negative 10 plus 4 is negative 6 over 9. So I'm left with negative 2 thirds on the left side and negative 2 thirds on the right side, and they're equal. That means my answer is correct. And I check the box and move on to the next example. Here's number 5. 0.4x minus 0.25 equals 1.75. Here you can continue working with the decimals if you prefer, but I always prefer not to work with the decimals, and I like to get rid of the decimals. So my first step, I'm going to write the decimals as fractions. So 0.4 is same thing as 4/10 x. 0.25 is same thing as 25 over 100, and 1.75 is same thing as 175 over 100. To change a fraction to the decimal, you would bring the 1 below the decimal and just put as many zeros, as many digits you have after the decimal. So same thing here, 1 below the decimal and as many zeros as you have the number of digits after the decimal. So 4/10 x minus 25 over 100 equals 175 over 100. Now in this case, my LCD is 100. I will have to multiply everything on both sides with 100 so that I have no more denominators. I do not want to deal with the fractions now. I just want to have integers, no fractions. So I'm going to multiply both sides of the equation by 100, both sides with 100. So let's multiply with 100 on the left hand side. 4/10 x minus 25 over 100. The nice thing about doing that is it's going to leave me with no more fractions. So 175, when I distribute, 4/10 times 100 is 40x minus 25 over 100 times 100 is 25. All right, 40x is equal to 175 plus 25. 40x is equal to 200. X comes out to be 5. Now again, before I box, circle, do anything to this answer, I must plug into the original one, check and make sure my left hand side and right hand side are equal, just to be sure that I didn't mess up along the way. There's a lot of operations you're doing when you're solving these multi-step equations, okay? So 0.4 times 5 minus 0.25 equals 1.75. So 0.4 times 5 turns out to be 2. 2 minus 0.25 is 1.75. So I should have just have the question mark sign because I wasn't sure if they're equal, but now I know 1.75 is equal to 1.75. That means I'm ready to box, circle, highlight my answer and say that this is my final answer. So in this video, we just saw the equations where we have one solution. There are some equations where there's no solution. There's no value of the variable for left hand side and right hand side. There's no value for the variable that will make my left and right hand side equal to each other. Those equations have no solution. So doesn't matter which value you plug in for the variable. You just cannot make the left side equal to right side. And then there's also some other equations which have infinite many solutions, or the solutions are all real numbers. In those equations, you can put in any value of the variable on both left and right hand side. They will always be equal. Okay, I'll share some examples of those in the next video.